Hi everyone, this lesson is about geometry basics. So we are specifically focusing on the terms used in geometry and some theorems. So let's get started. So what's geometry? Geometry is a branch in maths related to points, lines, angles, surfaces, solids, and everything else. Yep. So in our lesson, we are actually focusing on angle sums of polygons and angles in parallel lines. So, what's the importance of geometry in everyday life? So, I've included a picture of my wedding here. So, yes, this is in the Royal Arcade, and it is such a beautiful sort of like architectural work. If you look at the glass, the ceilings, the floors, the shop fronts, it has all to do with geometry and balance and how it is like sort of put together um, to look so amazing. Yeah. So, yes, this is the St. Paul's Cathedral, and yes, you can see that there are many geometrical shapes inside. So, geometry exists since a long time ago. Yep, so it's not a sort of like a new thing that we are learning just for now. Yeah, this is actually a trick eye, a 3D trick eye museum that I visited in Korea. So, it's actually a piece of wallpaper, but they are using the knowledge of geometry to sort of create sort of like a 3D feel to it. So because of the like sort of like the intelligent use of like angles and lines and everything, it makes the place look like it's 3D when it's actually not. So that's a lot of use of geometry here. So okay, let's look at angles at a point. So basically, there are two sorts of like two sets of angles. Yeah. So the first set is called complementary angles. So complementary angles will add up to become 90 degrees. So I drew this using the f of x software. So I actually drew a right angle. So obviously that's 90 degrees. And then I sort of like draw a line across, and then I sort of like have a automatic angle measurement here. So the first one that is measured is 31 and the second one is 59. So we know that 31 plus 59 will add up to become 90 degrees. Yep, so it means that 31 and 59 degrees are both complementary angles. So supplementary angles will add up to become 180 degrees. So a straight line is 180 degrees, and I actually drew just a line across this, and yes, 39 plus 141, it becomes 180, and therefore they are supplementary angles. Yep. It is important for you to remember this terminology because just in case questions come out to sort of name the set of angles or justify why the other angle has this value. So you can actually sort of like use this terminology. So in maths, we actually use sort of like a specific maths notation. So we have to use this sort of terminology. So now we are talking about angles in parallel lines. And so the first one is alternate angles. Alternate angles actually have equal values. So we can see that the two horizontal lines here are parallel. And if you imagine like sort of like the letter Z drawn here, so it starts here and then it sort of turns here and it sort of turns again here, and that's the letter Z. So can you see that at both turns the smaller angles are actually the same? So I actually sort of measured this automatically as well, and it sort of like generates the same answer. That means that they have the same value, and that's because they are alternate angles. Yeah. So corresponding angles are sort of like in the same position. They sort of sit in the same position, if you get what I mean. So these two angles sort of like have the same position, and therefore they are corresponding angles. And yes, we need to make sure that there are parallel lines, yep, over here to make sure that they are corresponding. Yeah. The third one is vertically opposite angles. They also have equal values. However, we don't need parallel lines in this case. We just need two lines intersecting each other, and the angles that's opposite each other will have the same value. The next one that we are looking at is co-interior angles. Oops, I just realized I spelled it wrongly. It's not angels, but yeah. Co-interior angles, and they are supplementary. Yep. So what is the meaning of supplementary? It adds up to become 180 degrees. So can you see that between the two parallel lines, there is two co-interior angles, and they will add up to become 180 degrees. The next thing that we are learning is triangles. So triangles can be named or classified by their angles. So if we look at the first one is an acute triangle. That's because all the angles are acute. Yep. So all the angles must be acute. So what happens if one of the angle is obtuse? So obtuse means that the angle is more than 90 degrees. So if the angle is more than 90 degrees, one angle is obtuse, we have to call this triangle an obtuse triangle. Yeah. So can all the angles be obtuse? Nope, we can't, because all the interior angles will only add up to become 180 degrees. Yeah. And the third one is pretty self-explanatory. That's a right angle triangle. That's because it has a right angle inside the triangle. Okay, so now we look at triangles that's classified by the side lengths. The first one has sort of like lengths of different sizes, and therefore, do you notice that all the angles has different values as well? So this one is called a scalene triangle. The second one is an isosceles triangle. An isosceles triangle has two equal sides. Yep. So that means that two of these sides have the same length, and therefore I marked it this way. So if two of the lengths are the same, you can see that two of the angles are the same as well. Yep, so this is isosceles triangle. The third one is equilateral triangle. Equilateral triangle means that all the sides have the same length. Sorry, I forgot to mark this one. I was doing this in a rush. So three of these are the same length, and therefore they have the same angle size, and it has to be 60 degrees because the total angle in a triangle is 180, and if you divide 180 by 3 equal sides, it's going to be 60 degrees. Yep. And let's look at quadrilaterals as well. I know that you're familiar with this. Yeah. So I don't really want to elaborate further on this. It's just to sort of like a quick revision. If you are not clear about this, please pause the screen, have a look at this. I don't think it's gonna be hard. Yeah. And then yeah, the last thing that we are learning is polygons and the sum of the interior angles. So there is this formula that's S equals to 180 times n minus 2. So S is actually the sum of angles equals to 180 degrees times the number of sides of the polygon minus 2. So we need to also be aware of regular polygons. So what is a regular polygon? It is polygons, they are polygons that have equal sides and equal angles. Yep, I'll show you some examples over here. So the first one is a pentagon. So this pentagon, if all of the sides are of equal length, then it is actually a regular pentagon. So in order to get the sort of like the angle of one side of the pentagon, we have to use this formula. So this formula again is to find the sum of all the angles in the polygon. So this will be 180 times 5 take 2, 5, because the number of sides in the pentagon is 5. So this is the sum of all the interior angles, and if you divide it by 5, you get 108 degrees, which is one angle in the pentagon. So the rest will be the same. It is the same working for the hexagon, the heptagon, the octagon, Octagon is 8 sides, yeah. Nonagon, decagon, yeah, this is just for you to familiarize yourself with the terms, yeah. So for hexagon, it's still the same formula. And can you see, compared to the first one, the only thing that changes is the 6, and that is because it has 6 sides, yeah. I do not really want to elaborate on this because I think this is sort of like easy. So if you find it like sort of like if you want to analyze this further, I'm happy for you to just pause the screen and just, yeah, have a look at this, yeah. So the last thing that we are learning today is the exterior angle theorem. So if I am drawing this triangle over here, yeah, and I sort of extend one of the sides so that it's a little bit longer, yeah, and again I'm using the measuring, the automatic measuring, the angle measuring thing. So this is 83 and this angle is 51, and there is also an unknown angle. We know that the unknown angle is actually 180, take 83 degrees, take 51 degrees. So this is sort of like supplementary. Yeah. And also, if we focus on the line over here, the unknown angle and the angle 134 degrees actually are supplementary as well. And therefore, this means that the sum of these two opposite interior angles will equal to the exterior angle over here. So interior angles means that the angles that are inside the triangle, if that makes sense. And the exterior angle is the one that's outside of the polygon, if that makes sense. Yeah. So this is the end of our lesson today, and happy studying. Bye bye.